Hello everyone, bonjour tout le monde. Welcome to Concordia University's fourth space. Thank you so much for joining us for AACE International 3+1 Construction Elevator Pitch Competition. Whew, I'll be passing along to our organizers in just a minute, but first, to help situate you, we are streaming to YouTube live from Fourth Space, which is located on unceded Indigenous lands here in Jahagay, Montreal. As caretakers for the lands and waters we are meeting on, we'd like to extend our gratitude to the Kanyaskahaga Nation for their teachings about the earth and our relations. At Fourth Space, we work with our university community here at Concordia to mobilize and exchange knowledge by co-creating daily activities. So today, it's our great pleasure to have collaborated with the AACEI Student Committee and the CICIEM Research Center at Gina Cody School here at Concordia University to make this event possible. It's now my pleasure to pass the floor to Profs. Moselli and Nick Bach. Over to you.
Okay, thank you very much, Anna. Is it on? Is it working? Perfect. Hello, everyone. Welcome to the fifth, I don't believe that, the fifth annual 3 minutes, and now it's 3 minute plus one thesis presentation for construction students. I won't speak too much. I just wanna, I was thinking when I was sitting there, I was thinking about back in 2017, the idea was pitched to the AACE board at Montreal section, Montreal chapter. And I wanna thank them for being supportive, for trusting in us and the students. These students did a fantastic job. They took it in only 4 years, 4+ years, from a small competition, which happened in one of the rooms and was only attended by, I think, 6 or 7 Concordia students. Some of you were not even a student back then. Into some international. Like this year, we really had hard time to set aside a lot of international applicants who were of high caliber, but the competition was high. And also, I want to thank CCEM for supporting this event, because that's one of the things that is scaled up the entire thing. And without further ado, I'm going to invite Professor Salman Moselhi, the founder of the CCEM Research Center, to open this event of this year.
Thank you very much. Thank you very much. Really, I'm delighted to be here with you this afternoon on that annual event. And before we start, I would like to thank the student committee who worked diligently to make this a reality for you. And I would like, when I read the names, we have members of the organizing committee, and we have also a set of volunteers. So I'm going to name the committee members, so please raise your hand and be recognized. Dana is the president of the committee. Abdel Hadi, Shuru, Arham, Amr. All of you, raise your hand, one shot. These are the committee members. Thank you all very much. Also, the set of volunteers, we have Azeda and Jedobe, Julia, and Dilaram. Please raise your hands and be recognized. Thank you very much for the good work you do. Again, I would like to thank the judges for being here, judging the work. I would like also to thank the sponsors of the event. And indeed, I would like this beautiful collaborative work between AACE Montreal section and our CCM, and particularly the student committee that works for and as a part of AACE. This is something really beautiful. I understand we have a number of applications that were very close to 30. Only 1/3 of that was selected, and we're going to hear all of that on 3 streams. One of them is, I understand, planning and probably planning and control in construction. That is one group. We have 4 theses to be presented. We have also another group in ICT and AI. A lot of talking about AI these days. I think you should embrace that in your own work. This is the future of our industry. And then occupational health and safety. We cannot go without having too much injuries and accidents on our job sites. I don't want to take too much of your time, except to wish you all, particularly the student participants, those who are going to present your thesis, good luck. And again, I would like to thank my friends here from AACE, and over the years who have always been supportive of university activities, including lectures, and as a president of AACE, behind all of the support. Thank you, all of you. The floor is yours.
Hello, everyone. Welcome to AACEI 3+1 Construction Elevator Pitch Competition. My name is Dana Shamsullahi, President of AACEI Montreal Section Student Committee. Thank you to each and every one of you who are being here today with us, either in Forte Space or through our Zoom platform. It's so exciting to see professionals from academia and industry, as well as potential students, all gathered here today for this competition. This event is organized by AACEI Montreal Section and CCM at Concordia University. Unfortunately, the director of AACEI Montreal Section, Mr. Hajir Emrani, couldn't join us today. I would like to welcome our jurors, Professor Pohanchen from Concordia University, Mr. John Prizio from Hatch, Mr. Didier Changfu from Turner & Townsend, Tala Harb from WSB, and Mr. Thompson from HKA. I would like to invite my colleague, Shuruk Qarib, to provide details about event rules and stages.
Hello, everyone. So we've received so many strong we received so many strong abstracts from top universities all over the world, which made the selection processing very hard and very challenging for us. We received approximately 30 abstracts from top universities and would like to thank each of them for their submissions. After careful peer review process, we were able to select 10 students to reach to the final stage and present the research pitch today with us. Before starting the competition, I would like to announce the rules and regulations to have a smooth transition during the competition. We have 3 streams, as mentioned by Professor Musalhi, and each stream, the first stream, we have 4 participants, second stream, we have 3 participants, and third stream, we have 3 participants as well. Each contestant has 4 minutes to present, and then followed by 4 minutes of Q&A session by the jurors. The audience questions will be collected, screened, and forwarded to contestants at the end of each stream, if there is enough time. Maximum allowed time for each contestant is 4 minutes, followed by maximum 10 seconds to close their presentation, otherwise we will have to cut you through. We will have a break for jurors and audience to vote that will be announced at a later time. Your vote will be super important for us because you'll be having the opportunity to select one of our winners. Today we will have 6 winners, not only 3. We have 5 top winners and 1 selected by the audience. For our first track, we will have Amr Alam as a moderator, and now I would like to invite him to begin our competition, and good luck, everyone.
Thanks, Shuruk. It's a pleasure to be here to moderate this session or this stream about the project planning and control. Ladies and gentlemen, let's start the exciting part of this day. The presenter today, they are going to present the research ideas to bring us with the innovative and cutting edge technologies to shape the future of our construction industry. I have no doubt that the presenters of today will change our way of thinking about the construction industry in terms of planning and controlling the construction projects. Let's get started by our first presenter, Abdul Majid Irfani. Abdul Majid, are you ready?
Hi, yes.
Judges, are you ready? So let's kick off some of our finalists. Abdul Majid, you have got 4 minutes to present your research. Your time starts now.
Okay, hello everyone. Thanks for this opportunity to share my research about artificial intelligence application in construction risk management. Cost overrun and delays always recognized as a major challenge of delivering construction projects. Specifically for large projects, When the size and complexity of the project increase, the difficulty and challenge of delivering the project on time and within the budget also increase. Risk management is recognized as a tool, as a practice that help the project team to plan ahead for those risks and challenges and opportunities to have a better project delivery. However, how well does risk management perform? What's the relationship between risk management performance and project delivery performance? Current risk management practice and research mostly focus on experience and opinions of the subject matters through workshop and surveys. And mostly those practices focus on ex-ante analysis in the early phase of the project. In my research, I started a data-driven, artificial intelligence-based, and using an exposed risk management perspective. In particular, I asked 4 research questions. We believe each project is unique. Are project risks really unique? Can we use historical data to leverage those lessons learned for predicting risk for new projects? How will the project team identify the risks? And what is the relationship between the risk management performance and project delivery performance? I collected a large database of 70 major transportation projects in US. The project included highway, bridges, tunnels, all around the US. As I have thousands of pages of documents to analyze, I need to utilize AI to help me to automate this process. I use natural language processing to help me to remove those manual works to understanding this text, the meaning of the words by using the word embedding models. So word embedding models help me to capture similar risks from different projects, although the project team used different language. At first, I found that project risk, although the project is unique, is not unique. Second, I developed a tool that this machine learning-based tool get the project features from the user and then predict the potential list of the risks for the project team. Interestingly, when we tested that data-driven tool, it almost covers 70% of the risks by using the similar past projects. When I look at the risk lifecycle, we try to first model each risk's lifecycle, and then using those lifecycle of the risk, identify and measure the project team overall performance. When I look at the project team risk management behavior, I found most of the time, not only project team identify risk in the initial phase, they have to add a lot of risk during the projects when they have new information about the projects. Interestingly, only 65% of those risks finally happen. I found project team that have a doer behavior, means actively during the project identify risks, continue to add risks, perform better in delivery of the project in terms of the cost and the schedule. In summary, my research introduced a data-driven, AI-based for predicting risk, for tracking risk, and for helping the project team to have a better project delivery. Thank you.
Time is over. Perfect.
Well done, Abdelmajid. That was under the wire. Now I'm going to the judges. Judges, I have got 4 minutes on my clock for questions. Anybody? Okay, go ahead, Professor. Yeah, please.
First of all, thank you very much for the presentation. My question is, what is the need of using AI for risk management? Because thank you. Because I think the number of risks for transportation projects or for general construction projects are more or less the same. And then any experienced engineer could easily identify the potential risks for each type of project. So what is the use and the need for AI for risk management?
Sure.
Of course, data-driven is very important. Then I'd like to know your view what is the importance of making use of AI? Thank you.
So, yeah, during my presentation, I forgot to mention that these 70 major projects include more than 10,000 individual risk items. So this kind of the risk management that they do in their projects, they include the details of each risk. And the reason that I used the AI was that I wanted to understand and find the similarity of the words. You can be a project team, identify a risk with a different language, and then you need to go back and identify those risks that are similar, but sometimes added some context of the project. You may add the name of some utilities to your text. And that's the reason that to avoid those manual work, we did this kind of automatic process using AI. But at the end of the day, we developed a summary risk breakdown structure, which is include only 70 risk items, which these 70 risk items cover half of the database. So most of the time, there is a huge similarity. That's right.
Thanks, Abdelmajid, for the clarification. We have one more question from the judges. Yeah, go ahead, please.
Good afternoon, Didier Trunkfutter and Townsend. Can you explain how AI is going to be fancied in applying to project delivery performance, and please justify how AI is a great tool in that field? Thank you.
Sure. From my point of view, the most importance and help of the AI in this kind of research is to help to leverage lessons learned from the previous project and avoiding repeating mistakes. So sometimes some project in United States, in one state, did a project in a similar circumstance that you are going to do a new project. You can use those lessons learned by having their data. So this AI helps you to use those data in automatic manner.
Thank you, Abdelmajid. Let's keep it going, ladies and gentlemen, and keep this momentum up. Let's introduce Mohammed Sharifi. Mohammed, are you ready?
Yes.
Okay, Mohammed, your time starts now.
Okay. Hi, everyone. Broadband is becoming a necessary and basic infrastructure facility in the US, especially after the pandemic, when most of the essential activities start shifting online. Traditionally, the broadband service are provided by the private sector, and there are a lot of rural and less populated areas which are suffering from inadequate internet or broadband service. At this point, a public-private partnership or P3 is regarded as a promising approach to address these difficulties. But the risk is always with the P3 contract, and proper risk allocation is a key factor. However, there is no existing study related to the risk allocation in the US broadband P3 market. So objective of this research is to identify the pattern of risk allocation in the US broadband P3 project and compare the result with the other mature P3 sectors such as transportation. To do this, a list of 23 risks are provided from the literature review, and then by the content analysis, the risk clauses are extracted from the contract, and then two analysts determine the risk allocation, and finally the results are validated by the inter-rater test. The data in this research are provided from P3 databases, which include 6 projects, and represent the whole population until 2021. The risk allocation pattern are represented in some heat map, as you can see here, and the results show that the risk, some common and important risks such as interest, inflation, and public opposition risk are not mentioned in this in any of the project. And besides that, most of the risk, including 9 risks, allocated to the private sector, and the public sector only take 3 risks, and 3 other risks are shared between the public and private sector. Compared to the other P3 sector, such as the transportation, risk of change in law and permit are traditionally taken by the public sector, but they are shifted to the private sector in this research. And some other risks, such as expropriation and schedule delay, are usually taken by one sector. But in this research, I mean, broadband project in the US, they are shared between the private and public sector. The different risk allocation pattern, beside other clues, such as a limited number of data, show that US broadband P3 is in infancy stage, and there are huge uncertainty in related policies. The finding of this research contribute to knowledge related to the contract design and risk management. Thank you.
Thank you, Mohammed. Thank you, Mohammed. Thank you. Let's go to our judges to see what they have to ask. More questions? Okay.
Thank you for the presentation. My question is, PPP is a very broad and general idea. And in your research, did you take account of all different sorts of PPP projects? And then how are the risks different from different types of PPP projects? Thank you.
Thank you for your question. We consider all kind of PPP contract because the number of the data was limited. So we just have 6 projects, and we consider them and focus on them to find the risk allocation in this project.
Any more questions? Okay, thank you, Mohammed. We continue, ladies and gentlemen. Just to remember, all of these contestants will be available for your vote for the Audience Choice Award. So keep it going. Our third of 10 today is Mohammed Sharif. Mohammed, are you ready?
Yes, I am.
Okay, Mohammed, your time starts now. Go ahead.
Okay, hello everyone, and thank you for attending my presentation with title Automating and Optimizing Construction Process Using Computational Analysis. The objective of our research is to provide an optimization strategic model for the construction design with 3 main goals, which are the optimum cost, time, and sustainability. The typical construction design process starts with the global standards, which are the group of codes that all the different design trades should follow. The structures, the architectural, the mechanical, everyone. Then the special architectural design starts, which is basically done by the architect. And this stage involves determining the functionality of each of the available space. After that starts the structure element design, which involves the design of different structure elements like the slabs, beams, and columns. Then these 2 different design trades enters into a long, tedious process of negotiation and feedback. All this to reach a final design, which is not necessarily optimum, but it has to be safe. Our idea is to combine the structure element design and the negotiation and feedback process in one automated and optimized process. It starts with the conceptual architectural design. It's mainly an initial plan, architectural plan, which is converted into analytical model. And this analytical model is used for the structural design of different elements. This same analytical model enters into an evolutionary optimization engine, and through different iterations, the model will be able to achieve a final design which is optimum in terms of cost and environmental impact. It's worth mentioning that our optimization process depends on defining dimensional limit, architectural dimensional limits, which obeys the functionality of each of the available spaces in our plan. This is not just an idea. We have an actual working prototype, which we tried on several case studies, and the model was capable of achieving up to 20% cost saving per plan and up to 30% environmental impact saving. This environmental impact assessment is done through combining the model with revolutionary research regarding recycled plastic concrete. In summary, the problem which we are trying to solve is the repeated systematic design of the construction process, the tedious negotiation phase and change order, the unoptimized cost and time, and finally, the construction negative environmental impact. And our solution is a completely automated structural design, termination of the tedious negotiation phase, providing a design which is optimum and safe instead of just being safe, and try to promote the idea of sustainable environmental impact in the construction design. Finally, we have some ground rules for the model that we need to discuss. First, the overall floor area must remain constant. The structure height remains constant, but the cost of the structural columns decrease. And finally, the architect is the one who defines the dimensional limit that obeys the architectural requirement. Thank you so much, and let me know if you have any questions. Thank you.
Well done, Mohammed. Thank you. And time with just a little bit to spare. Now let the judges judge. Any questions?
Thank you. Thank you for the presentation. In my experience, a lot of projects suffer a lot of changes. You mentioned changes. How easy is it, or how difficult is it to maintain what you're proposing through a project that goes through a normal amount of changes or a significant amount of changes? How is that process?
So it's very easy, actually. So the idea is providing a structure element design tool for the architect himself or for the contractor. So the main idea is once the change is on the table, once the changing order is on the table, the architect or the contractor can use our model to prepare the whole structure design, including the new changes. So it's like providing, okay, instead of waiting for the submission of this changing and waiting for the structure design to take place, then the negotiation starts. It will be providing an ongoing overview or an image of how that change will impact the structure design itself.
Thank you, Mohammed. Thank you. More questions? One more.
When you're comparing an optimized design, how do you balance optimized cost versus sustainability?
Oh, okay, so that's the idea. So we have two approaches. The first one is the optimum cost in terms of the material quantity. So we minimize the material quantity. Then we introduced, as I mentioned, we introduced the concept of recycled plastic concrete. So we compare. So it's like a milestone. So the first step is decreasing the amount of material. Then by introducing the concept of recycled plastic, we were even able to decrease the amount of the material more. So instead of achieving, for example, a 20% saving, this percentage increased. And of course, the utilization of the recycled plastic will have had a very significant impact on the environment, which we calculated using different environmental assessment software like virtual environment and stuff and other softwares.
Thank you, Mohammed. Tala, we have room for one more question. You can go ahead.
When you speak about cost, optimizing cost, how does it affect your cost in a positive way?
So the decreasing of the amount of the material, so it's like the initial amount of the material is X and it's decreased by 20%. So that's what I mean by a positive impact on the cost. So it's like this amount of saving. And of course, this saving is not only for the cost, it also affects the time, because trying to terminate that negotiation phase will decrease the overall duration of the project, which is also a positive impact.
Thank you, Mohammed.
Thank you.
Last but certainly not least, ladies and gentlemen, let's introduce Ahmed Zalouk. Ahmed, are you ready?
Yes, I'm ready.
You have got 4 minutes. Your time starts now.
Compared to the United States, house prices in Canada have run far beyond what people earn. Canada needs 5.8 million homes by 2030 to address this housing affordability crisis. To respond to this high demand, panelized off-site construction is increasingly adopted in housing projects since it provides several advantages such as cost and time reductions. In the panelized method, panels of floors, walls, and roofs are built in the factory, then transported to construction sites for final home assembly, creating a unique construction supply chain with higher complexity and fragmented parts. Indeed, one of the biggest challenges of this method is the development of construction schedules that consider not only production at the factory, but also delivery logistics and on-site assembly. However, current scheduling practices in panelized construction companies still lack integration of different supply chain paths, causing unstable performance of the supply chain and underutilization of resources, usually leading to cost overruns and the project delays. In this context, this research project aims to help panelized construction companies expedite home supply in Canada. The goal is achieved by proposing an automated master scheduling system that employs the hybrid simulation paradigm to develop an integrated supply chain model. The proposed system maps and models the unique procedures of the panelized construction operations in a multi-project supply chain. Moreover, it integrates the three main phases of the supply chain: production phase, transportation phase, and the on-site assembly phase. It also considers multi-production lines in the factory and the realistic features of the transportation and on-site tasks. The system provides several features such as GIS integration, managing multitasking and shared resources while accommodating various home designs. Also, it takes into account various logistics and resources such as site crews, cranes, trucks, and trailers. The system enables generating a master supply schedule for the entire supply chain in about 7 minutes, including the following outputs: production schedule, craning and on-site schedule, loading and dispatching schedule, resource allocation for different operations, and resource utilization analysis. A prototype of the system is developed and validated through a case study for a panelized homes company. The system can provide several benefits to the industry, such as improved project control in terms of cost, time, and risk, reduction in pre-construction planning costs, efficient resource utilization by reducing the waste on the supply chain, and increased planning and scheduling flexibility. In implementing the proposed method, panelized construction companies can expect a proper supply chain management that ensures a consistent supply of homes at construction sites, thereby mitigating the risk of construction disruptions, leading to additional costs and schedules. Eventually, panelized construction companies can significantly contribute to solving the housing affordability crisis in Canada. Thank you.
Thank you, Ahmed. Well done. Now let the judges judge. Any questions?
Thank you for the presentation. I have a question for you. You've been detailing about the automated master planning applied to panel home supply chains. We have elaborated much more about the advantage of that. Any disadvantage now we need to consider about this home supply chain? You can mention a bit about a couple of disadvantages which can affect have big effect on our supply chain. Thank you.
You mean disadvantage of the system or generally using the panelized method?
Both of them.
Actually, the method, it has advantage in terms of time and cost because it expedites the home supplies. However, still, it has a lot of challenges because the construction is actually separated into 3 phases in a factory, transportation, and site. This is a big challenge for the industry because managing these 3 phases together in a time manner. It's a big challenge, as I mentioned, especially in terms of scheduling all the resources simultaneously involved in these 3 phases. Of course, the advantage of the system, it will give automation opportunity to the companies, that really helping them to visualize the entire supply chain, making analysis of the performance, spotting the bottlenecks in the supply chain, and of course, expediting the home supply.
Thank you, Ahmed.
Thank you.
Yes, I have a question as well. I very much like the idea, by the way. Has this been considered for remote locations and places that are difficult to reach? It seems like a good way to do that, to reduce the labor at site.
Yeah, actually, the idea that of integrating the GIS within the system, that all the questions of the project are included in the beginning. So the transportation time, resource transportation between the sites and between the factory to the sites is also considered as a time of movement of all resources. So if we have a remote location of a site, it will be located on the map. The time to move the resources from the factory to the sites and so on will also be computed automatically within the schedules created. So I think there's of course opportunity to add any location of the sites within the schedule.
Thank you. Any more questions? Okay, go Professor Chan.
First of all, thank you very much for the presentation. My question is, in your design, do you consider only the domestic supply chain and its corresponding management, or you also take into account overseas supply chain? Thank you.
No, for the time being, we just consider the domestic in terms of location of the factory and the city of the factory. So, for example, now if the factory in Montreal and the other site within Canada, we can manage this by just transportation of trucks and so on. But overseas is not included in this model.
Thank you, Ahmed.
I apologize. I don't know what's the problem with my camera, so I apologize for this.
Thank you, no worries. At the end of this stream, we are opening the questions for the audience. So I've got 4 minutes on my clock for the questions from the audience. Anybody? This is for all the presentations, not only for Ahmed. Okay, go ahead, please. But sorry.
Analysis. So the EI risk analysis. My question is, the risk analyze and pick and select after the EI, are they considered systemic risk?
Abdelmajid, are you with us?
Yes, I'm here.
Okay.
So can you repeat the question? Are the risks systematic? I think you asked this, right? So the risk that,
okay.
Oh yeah, you can.
My question is, the risk identified, are they systemic risk that you can use afterward to manage the risk on your project?
Yeah, so the risks that included in the risk registers are from the planning, construction, everything. And those risk registers through the project lifecycle updated. So project team, during the project, they found new information, they add something new to the risk register, or something dismissed, never happened, they close that risk. Or sometimes they put comment about some of the risks that they encounter. So we use those all lessons learned, all those information from the project team that deliver those projects and find a way to use them automatically using AI.
Thank you, Abdelmajid. More questions from the audience? Okay, Professor Mazdak.
Thank you very much. So this is a question for the third presenter. I wonder if the sources of indirect cost are also being taken into consideration in your optimization problem. That's one question. The second one is whether the cost is being dealt with as a deterministic, or you also do look at any type of contingencies or deviations from the expected values for unit cost and so on and so forth. Thank you.
Thank you. So thank you for the question. So up till now, we are very concerned with the design cost. So it's mainly designing and planning in the preliminary or the stage before the construction itself. But right now we are trying to include more analysis for the indirect cost, of course, because this is actually a very important comment that we received before. So we are including more analysis for the indirect costs. This is the first thing. And the other thing, I'm sorry, what was the second question again?
Whether the cost is being considered as deterministic, or let's say there's some sort of randomness associated to it, any uncertainties or any contingencies in cost.
Yes, exactly. So the concept of uncertainties and the indirect cost are both, right now we are working on integrating this inside our analytical model. We are actually collecting bigger case studies to integrate this inside our model.
Thank you, Mohammed. We have room for one more question. Anybody? Okay, Professor.
Hello, I have a question for the first presenter, Mr. Irfani, using the AI for risk management. So I remember that you mentioned that you achieved about like 70% accuracy after applying AI for the documents. Mm-hmm. How feasible is it to use that accuracy in real practices? So, and also like what would be like limitations in like the future works to be involved to improve that accuracy?
Yes, that's a great question. So in the practice, when we share this tool and models with DOT's, Department of Transportation, US, so they look at this as a consulting tool that help them to not to start from the scratch. And then the final decision is always upon the project team. And the good part of this process and algorithm is that when you have new data, when you have new projects, then you can update your database. And then by updating the database, then you will have a better result because you have more data points, more experiences over the past projects.
Thank you, Abdul Majid. Thank you, everybody. Thanks for the judges. That's it for the first stream of our competition. That's it for me. Over to you, Julia.
Thank you very much. Hello. Ladies and gentlemen, it's my pleasure to introduce the second stream of this competition, ICT and AI in construction. As we all know, technology is playing an increasingly important role in the construction industry. And today's presentation will showcase some of the cutting-edge research being done in this field. From using AI to optimize construction process to leveraging ICT to enhance project collaboration, these students have tackled some of the most pressing challenges facing our industry. I am eager to hear their insights and ideas, and I know you are too. So we are going to start now with our first presenter, Amir Sanatgar. Amir, are you with us?
Yes, I'm ready.
Are you ready? Okay, your time starts now.
Okay, hello everyone. It's my pleasure to be here. And can I ask you to think about this statement just for a few seconds? Construction industry in 2020 lost 1.86 trillion American dollars just for bad data, 13% more than Canada's GDP in that year. Well, of course, we saw progress in the adoption of construction industry to industry 4, like automated construction and progress monitoring, applying robotics and drone in construction, digital twin, AR and VR, and so on. But the bare minimum of intelligence is learning from our own previous work and using our knowledge in future projects. Consider an international company with several projects all around the world. Should similar projects be archived separately just because they are in different languages, even if they are referred to the same themes? Can we not utilize our previous lessons? And all of us knows this frustrating sentence: the construction industry suffer from two things, overrunning costs and overrunning times. So what? What its reason? A significant portion of overruns and changes occur due to the lack of 360-degree insight into the project situation in any phase of project, from planning to operation and even rehabilitation and so on. Or in other words, a lack of data strategy. Apart from that, think about the retirement and resigning in construction organization. From 2022 to 2027, more than 156,000 seasoned professionals will be retired in Canada. How much money, time, and efforts does an organization pay to change a junior worker to a senior? Isn't this a valuable asset for companies? How can we transfer knowledge and skills? In this regard, we are developing a knowledge management system that employs semantic, web technology, and AI. It consists of three different things. First, we capture all project data, including data silos, databases, contractors, specification, or even emails. Then we identify all relevant and important terms and concepts by conducting text mining. Also, we review the results with the help of knowledge experts through extensive interview and meetings. After that, create a dictionary shape, which is lexicon of all concepts that we want to capture in our systems. And in the second phase, we are going to put them in a hierarchical shape, which is a taxonomy. And finally, develop an ontology by adding semantics through adding all rules and restrictions to this system. To wrap up, I want to mention this system conforms to the CRISP and cross-industry standards process for data mining, and will be developed as a semantic layer in the enterprise data architecture.
1 minute.
Okay. To main contribution of this research, I would like to say first, share meaning and knowledge between human and machine across different system and application. Second one would be problem solving and decision making would be easier by having a holistic view of all existing data as a priceless asset. And finally, reuse farmer projects knowledge to identify bottleneck challenges and contingency. Thank you.
Thank you, Amir. Thank you very much. I will now open the floor for questions. Do any of the juries have any questions? No questions?
Thank you for the presentation. Do I understand that every construction company would have to set up their own knowledge management system?
Right.
And how practical is that?
Okay. I want to look at your question from two different perspectives, as a researcher in academia and as a project manager in a company. For sure, for a startup and a small company, it would be better to work with another company that provides the semantic web technology. We have a distinguished company like Link Data or full party companies to work on this system, and for the startup and a small company, they can work with them. But for a bigger company, it is essential to have their own knowledge management system, because they should bring all data and customize this system for own system. And as a researcher in academia, we saw a bunch of similar research in other universities, but we should customize for each aims. For example, I worked on a change management and financials, but maybe, for example, in Eindhoven University, Peter Pauls works on in another site for sustainability, or McCabe in Toronto University worked on a risk management with the knowledge management system. So to make short my answer, it's necessary for a huge company and bigger company to have their own, And for a small company, they can go and work with another company to provide this system for them.
Thank you, Amir. One more question.
Yep.
Oh, thank you for the presentation. My question is, in your system design and development, did you do it from the perspective of the contractor or designer? If it is from the designer, would it be easy for you to modify it and for it to be implemented for the contractor or the other way around? Thank you.
It doesn't matter from each perspective, because consider this project, we capture the important things is define the project with all data that they have, and we capture them and customize it and select based on the text mining that we are doing, and select the main concept. So I, as a contractor, for example, for risk or for change, for example, the resource of risk is important to me, so I should capture it for the taxonomy. So it doesn't matter from each perspective. All of us should have, but it largely depends on our aims. If our aims, for example, to just have this system for a future plan, so it's another story. But if we want to work with this system for, as I mentioned, for some aims, so we can use it and select another type of terms and concepts. My project
Thank you
works
very
with
much, Amir.
Okay.
Sorry, we're running low in time here. Thank you very much for your presentation. I would like to introduce now the second presenter, Saman Davari. Are you here with us?
Yes, I am.
Thank you. All right, are you ready?
Yes.
Okay, your time starts now.
Hello, everyone, and welcome to the presentation of my thesis. So in the context of built asset industry, we are currently witnessing a rapid digitalization through the use of emerging concepts such as digital twin, cyber-physical systems, IoT devices, and so on and so forth. And of course, this is very good and promising because it provides many opportunities to improve performance, quality, and value of assets and resources. But when we are specifically thinking about the concepts of digital twin or cyber-physical systems, most of the recent studies are focusing on their applications or functional features without or limited investigations about their main characteristics, dimensions, definitions, mechanisms, and principles that support coupling of physical and digital built assets and resources. So these are the important research gaps that must be investigated in details before implementing such concepts and technologies into operation. So the first question here is, what kind of constructs and principles need to be defined in order to develop a digital twin or any other instantiations across assets lifecycle? So for that, we started to develop a taxonomy of lifecycle information coupling of built assets and resources to structure the body of knowledge using 8 high-level dimensions. These dimensions cover various aspects and characteristics of physical and digital information coupling. For example, at level 1 of this taxonomy, we define the main types of information couples, or what would be the main coupling purposes or outcomes and their impacts on environment, economy, governance, and social aspects. What actions we need to take for developing an information couple. At level 2, we define detailed functional or representational metrics to measure the degree of coupling between the physical and digital. And of course, we may find different types of coupling enablers to facilitate any coupling process in the built asset industry. Using a defined dimensions of taxonomy, another objective was understanding how we can operationalize and instantiate such constructs in real practices. To address this objective, the key principles of the taxonomy were framed based on the common operational needs. So here on the right side of this slide, we can see coupling action framework, including 5 main components: coupling purposes, outcomes, actions, enablers, and data categories that are actually coming from the taxonomy. So these components are linked through a mechanism to support development of potential information couples across lifecycle stages. So in conclusion, the proposed taxonomy and its instantiation framework provide opportunities to structure the body of knowledge and understand better the concept of asset coupling in the built environment. They both can be used to close the information and collaboration gaps among stakeholders. So in real practices, coupling action framework can play as a suitable reference to clarify for owners or project teams what steps or actions need to be taken in order to develop an information couple such as a digital twin for industrial uses. Thank you very much for your attention.
Thank you very much for the presentation. Thank you. I'll now open the floor for questions again for our jury. You have 4 minutes. Any questions? Nope. All right. Thank you very much. We are going to go to the next presenter, Austin McLemons. Are you there?
That I am.
Are you ready? Yes, your 4 minutes starts now.
All right. Hi, everyone. My name is Austin McClimans. I am a PhD student at Penn State University, and I'm here to tell you a little bit more about my research, which is supporting the information exchange between a BIM model and a robot using parametric modeling. Now, the overall goal of my research is to create the necessary framework for transferring data from the BIM model to a robot supporting systems of a lower level of development. So systems in the BIM model aren't necessarily made equally. Some have more details, like mechanical systems, while some are just represented as a simple texture, like wall systems. So in order to have robots work on the site, eventually we're going to need to be able to extract this information from the robot. So the first objective that I set was developing a system architecture for this process. The first part was involved with this was task planning, where we got the geometric data and technical specifications, incorporating that with the material content libraries and extracting that information from it, supplementing the information as needed. After that, it went to the task decomposition, where information such as fabrication, logistical information, and scheduling information is combined with the data previously extracted and with external data sources such as the topological data, weather data, and the capabilities of the robot, so it can be formatted for it, and the robot will be able to eventually create its task, carry out its work, and execute it, and providing feedback to the user overall. This leads into the objective 2, which takes a little bit more in-depth dive into the overall process. Objective 2 looks at adding the supplemental information to the model. So if we take masonry construction as an example, just typically represented as a texture, we need to be able to add in the block for it so we can extract the location of it. So where is it on the site? We need to know the orientation of this block, and we need to know what type it is. Is it an 8x8 by 16-inch CMU, or is it some other size? We need to know this information. So we're using parametric modeling to model each CMU for the wall structure. After that is modeled, we can extract it, and then that leads into objective 3, where we can start formatting this information a little bit more. We format it based on sequencing and the traditional construction method. Right now, this is still a little bit in process, but we've been taking a very linear approach to sequencing the work for masonry construction, starting in one corner of the wall, working our way across, and keep going up until the work will be completed. Now, for a little bit of verification to this method, we started some preliminary tests for this using a Husky A200 robot equipped with a Jetson Nano and a Z2i stereo camera, so it's taking 2 pictures at the same time in 2K resolution. What we're doing is we're using this for photogrammetry and reality capture of a mock construction site. So a worker went and placed the blocks in the correct locations based on the information that would be sent to the robot. The robot would then be drove around the wall, taking pictures at specified intervals, and eventually this information would then be reconstructed in programs such as CoalMap, where we get another 3D image file that we can overlay on top of the other model. And from there, we can see exactly what's going on. We can see how close it resembles to it, and eventually be able to see that this could be used for progress detection, monitoring, or if the robot was correctly carrying out its work and placing the block in the correct location. I would like to extend my thanks and open up for any questions. Thank you very much.
Thank you very much for your presentation. Now opening the floor for questions. Yep, please, Professor Chang.
First of all, thank you for the presentation. And my question is regarding the robot. I'd like to know what are the tasks or jobs that your robot is working on or your robot can do, and then how specifically can a BIM model contribute to the tasks to be implemented by the robot that you're experimenting in your system?
So right now, the robot I've been working with, main capability is more for progress detection or monitoring, eventually would be adapted for quality control. We have another robot in our department that has a robotic arm. So the goal would be eventually to have it be able to carry out its work for either material delivery or placing the block in its final location. For the BIM model, I believe it'll be a great source of data for the project. There is some other research out there, right, where shows examples of information getting extracted and eventually the robot being able to conduct its work, such as painting walls or something along those lines. But there's a lot of challenges that would be in the way of fully implementing that at the moment.
Thank you very much. Any other questions from the jury? One more. Mr. Thompson, please.
In your example, the robot was helping identify that the wall had been built in the correct location after it had been done. Do the robots have a way of helping the people on site determine where they are to build certain aspects before they do the work?
So in that experiment, no, it did not. That experiment was set up to make sure that the information was getting across correctly from the BIM model. So we had the information that would be given to the robot. We had a worker put the blocks in the correct location, measure it out, lay it out, and stack the CMUs accordingly. But in the future, that would be one of the next steps.
Thank you. Thank you very much. We have time for one more question from the juries, and then I'll open the floor for the audience. Please.
Thank you. My second question is, the system that you develop, is it for general robots or it is for like a specific type of robot?
So right now it's more specifically tailored to the Husky robot, but the intention would be to eventually develop it to make sure it could be adaptable. Methodology surrounding it could definitely be adaptable to other robotic systems.
Thank you very much. I would like now to open the floor for the audience. If anybody have any questions for any of the three presentations that we just heard, please let me know. Dr. Nickbeck, can I ask you to come here just to facilitate the process?
Thank you all. My question is addressing the second presenter, Saman, I think. I'm asking about what's happening beyond the taxonomy. So how is the taxonomy being implemented? Is there an ontology as well, or is just staying at the level of taxonomy? And if the latter, how? If the former, how and why? Thank you.
Very good question. So the methodology for development of a taxonomy was adopted from the Nickerson. It's a very famous methodology for development of a taxonomy. So the first step was selecting a meta characteristic and then conceptualizing and somehow design the new characteristics of the dimensions. For each dimension, a coding system was adopted from to select the meaningful characteristics or terms in the literature. And so for implementation of the taxonomy, this project used two case studies that they were based in Montreal, and they were evaluated and validated in the different based on different purposes. So the outcome was very interesting because each company had different approaches, but the outcome was very helpful for the companies to decide what the steps or actions need to be taken from the taxonomy to create their own digital twin.
Thank you. Thank you very much. Any other questions from the audience? would you please come here so the presenter can also see you while you ask the question?
Hello, so I have a question for the first presenter, Amir, who has done a research for using AI for knowledge management. So I have a question that for the newbie companies, like that the companies just started their work, what would be the strategies for achieving and accumulating the data set for using AI? Because the amount of data set is very important when applying AI to ensure the accuracy. So what would be the strategies for those new studying companies for applying AI for knowledge management?
Oh, okay. Of course, in all projects with artificial intelligence, the most and the first question is how we can gather the data. It largely depends on the scale of our works and in relation between other stakeholders. For example, in my case, for a research study, I work with the industry partner. But if you are, for example, you want to develop, you want to run a startup or company, so you can start with as a consultant in another project to gather the data, or maybe in some case you can talk to other company to work with them and gather data from them. It largely depends on your strategy and your connection with other companies higher than you or lower than you. Yeah.
Thank you. Thank you very much. We don't have any more time for questions. I would like now to end the second stream of our competition and introduce Arham, who is going to be taking from here. Thank you very much.
Thank you very much, Julia. Hello, gentle people. Thanks for joining us today, online and in person. My name is Aram Martinez, and it's a pleasure to be here with you in this special day to express our love for our industry and the passion and knowledge to improve it. I hope you are enjoying this exciting competition as much as I am, and soon be ready to vote for your favorite contestant. Let us now turn our attention to the third and final stream of this year's competition. It is a safety moment on occupational health and safety. Construction sites can be hazardous environments, and it is our responsibility to ensure safe sites and healthy environments for workers and everyone, especially now under pandemics. The students presenting the research today under this stream have taken this challenge, and their work will play an important role for the construction industry. From new technologies for mitigating risks to innovative approaches for improving workers' well-being. And before starting the presentations, I would like to remind the jurists to have ready your questions. Without further ado, our next contestant is Malcolm Dodson, presenting his master's research entitled Evaluating Occupational Exoskeleton Efficacy in Construction Toward Guidelines of the Construction Industry. Welcome, Malcolm. Are you ready?
Hi, thank you. Yes, I'm ready when my slide is up.
Perfect. The floor is yours. Please start now.
Thank you. Good afternoon. So, exoskeletons for construction. From the title of my presentation, you might be asking yourselves the same question I had when I first heard about exoskeletons. How does the health and safety of construction workers have anything to do with alien fighting robots? We first have to understand that workers in the construction trades perform manual labor that puts them at risk for so-called musculoskeletal disorders. So think of shoulder injuries, lower back pain, and even herniated discs that can change a worker's life forever. To give you a concrete example on rebar workers, in other words, a reinforced concrete example, a survey of 1,000 construction iron workers and rebar workers found that more than half of these tradespeople had back injuries during their career, and 14% reported doctor-diagnosed ruptured back discs. What's more, around the world, including in the Canadian construction industry, there's a growing shortage of skilled tradespeople in construction. So So how do we fight back against these high injury rates? A potential solution exists, and it's called an exoskeleton. You may have seen exoskeletons depicted in movies as wearable robots that are useful for fighting aliens, but the exoskeletons available to construction workers are actually mainly small and light mechanical devices that don't require batteries or electricity. They're designed to take the weight off the wearer's shoulders while lifting overhead, or off the wearer's back while bending at the hips. So imagine yourself picking up a box while wearing an exoskeleton for your back. As you bend at the hips, springs at the rear of the device stretch out, and the exoskeleton supports the force of gravity from your upper body. So as you stand back up again, the exoskeleton assists you by recycling and giving back this force. So after picking up the box, you do not have to contract your back muscles as much, and you could more easily take on a posture with a neutral spine, which promotes the muscles from your entire body to carry the load and not just the muscles from your lower back. Results like these have been seen in lab and field studies, but what's missing is direct evidence that exoskeletons reduce injury rates in the long run. And this evidence will come from long-term field studies. However, before a long-term study can begin, a problem arises. There are many clever exoskeleton designs, so how can we predict the most effective exoskeleton for a specific trade before investing in long-term studies? My proposed method, building off past research, is a standardized test course for a specific construction trade working on a specific type of construction project. So for example, rebar workers working on the deck of a reinforced concrete bridge. This test course will involve lifting, carrying, and placing heavy steel bars and tying rebar cages together. It will measure what difference an exoskeleton makes in terms of muscle activation and discomfort. Thanks. And these lab results will be compared with a short-term field test to make sure that the lab test reflects the real world. So the goal is to eventually have a standard test course for all of the major construction trades, so that any existing and future exoskeletons can be compared on the same playing field. And the most effective exoskeletons can then move on to these studies that look at their long-term health effects. I believe that exoskeletons can move us towards a future where tradeswomen and men can thrive in healthy careers. And we should move towards that future because they're the people that build and maintain the environments that touch all of our lives. Thank you.
Thanks, Malcolm, for your presentation. Now it's time for our question and answer session. Who has some questions for Malcolm? Yeah, please.
Thank you for the presentation. My question is, in your study, did you take age, gender, and other relevant issues into account? And then what would be the put on and take of time for the exoskeleton? Thank you.
Sure. I should preface this by saying that I think I'm one of the few contestants where I'm really at the beginning of my research. So the scope isn't determined yet, but we're hoping to have a gender balanced study, but still looking at probably a younger age range just because of health and safety concerns. But the framework will incorporate these different social aspects. And the take on how long it takes to put on an exoskeleton, to don and doff an exoskeleton will be an important factor in the evaluation, because if you put it on faster, it's performing better.
Yes, please.
Okay, it leads nicely into my question. I was going to ask you, perhaps you're at the beginning of your research, so maybe it's something you would want to consider. But by wearing an exoskeleton, is there a chance that you're creating another problem where someone's carrying something and it's different from their usual workflow and things like that? Have you considered that?
Yeah, exactly. So right now, because we're thinking of short-term studies, all we can look at is short-term discomfort. And the true measure will be in the long-term studies, are there long-term health effects? And that's really the big question right now. But the only way to measure that in these lab studies will be, does the exoskeleton, is it accepted by the workers, by their responses of using the exoskeleton, and does it produce any discomfort with the points where the exoskeleton contacts the body. So that'll be a part of evaluating the performance. Not just does it reduce muscle activation in your lower back, but also does it create discomfort at those contact points. So that'll be part of evaluating the performance for sure.
Thanks. We have time for one more question if you have, in case you have. No? Okay. Thank you, Malcolm. So our following presenter is Kyung-Suk Lee with his PhD research on the understanding of cognitive failures and anticipatory cues in worker safety performance. Hi, Kyung-Suk. Are you all set?
Yes, I'm ready.
Okay, please proceed.
All right, so despite continuous effort to enhance workplace safety, construction industry has shown a poor safety record with large number of the fatality and injuries. And among various causal factors, human error is one of the main causal factors in up to 80% of the accident across various industry. And skill-based and perceptual-based errors that are highly related to hazard identifications are recognized as the main contributor to accident at construction job site. Accordingly, various safety training have been developed to mitigate those errors by adopting several advanced technologies. But despite previous endeavor, it was observed that workers' hazard identification performance are still under the desired level, and around 30% of hazard are missed even after taking the safety training. So the fact that the available trainings are not as effective as they should highlight the need to investigate why the existing safety intervention failed to remarkably reduce those errors and identify strategies to maximize the effectiveness of safety training. To address this research gap, I have focused on the development of personalized safety training to effectively mitigate construction workers' cognitive error. And there are 4 key aspects of my research to develop the entire safety training. First, the simulation of construction environment. My research utilized 360 panorama technology to mimic the construction job site and provide realistic experimental conditions without being exposed to the actual risk. And creating realistic experimental environment is critical to provoking the naturalistic behavior of workers. And second part is monitoring workers' behavior and cognitive process using multimodal wearable devices. In my research, I have utilized 3 different wearable devices, which is our eye tracker, affineur, and wristband sensor, to understand workers' decision dynamic, risk perception, emotional state, and attentional distribution ability. And third part is the assessment of workers' hazard identification ability. So based on the collected objective data and subjective hazard identification answer, this research assessed the workers' hazard identification performance and developed the AI system, which can automatically classify various cognitive failures, such as attentional failure or inattentional blindness, to provide the personalized safety training. And lastly, based on the findings of previous thesis, AI-informed personalized safety training has been developed. So during the training, the worker will be asked to search hazard in the construction scenario
1 minute left.
while their physiological response are monitored. Then, embedded AI system will automatically classify the individual's own cognitive failure by synchronizing the collected data and provide the associated safety training. Now, I'm currently leading NSF ICOPS team in close collaboration with industry partner to transfer this personalized safety training into practical application. Therefore, this study is expected to contribute to both academia and practice. And in long term, the outcomes of this study will contribute to protecting thousands of workers and a remarkable decrease in medical costs due to the injuries and a notable reduction in project delay caused by the accident. Thank you.
Thank you very much, Kyung-Suk Lee. And now it's time for some questions. Do you have some questions? Yes. Yeah, please.
A very nice presentation.
Thank you so much.
I'm specifically curious as to how much effort has to be put into personalizing the recognition of environments such that you can recognize risks. Is there a lot of effort that has to be, like built into it? Or is it like a machine learning, AI type learning, so that when someone actually goes for the training, it's rapid? Like, I'm concerned as to the investment of effort to make that happen.
So for current develop the personalized safety training, it included some AI system which can automatically classify the cognitive failure using the multimodal psychophysiological metric. So to develop that model, we first investigate how workers' attentional distribution or risk perception influence their hazard identification performance. So even though so far the current version of the training system can automatically classify, but behind of that, there was huge effort to understand how we are going to synchronizing those objective and subjective data.
Perfect. Another question? No? Okay, thank you very much. Our last, but certainly not the least participant in this year's competition is Shashank Muley, with his PhD study to investigate the influence of personality on near-miss recognition performance on construction workers. When you're ready, the floor is yours, Shashank.
Yeah, thank you so much. All right, thank you so much for this opportunity to present my research topic on a study to investigate the influence of personality on near-miss recognition performance of construction workers. I'd like to start by this quote: "The near-miss reported today is the accident that doesn't happen tomorrow." To remove accidents and fatalities from the safety equation, it is vital to make early detection in the form of near-miss identification better. If we look at the CPWR statistics, for injury type fatalities from 2011 till 20, fall accounted for 53% of fatalities. Stuck by 26%, 10% for caught in between, and 12% for electrocution. Now, fall, stuck by, caught in between, and electrocution are famously known as the fatal four, which constitutes a huge block of construction fatalities. If you talk about near-miss, near-miss is also known as the close call, are those events that act as a precursor to any injury or accident on site. According to OSHA definition of near-miss, if there is a slight shift in the time or position, damage and/or injury could have occurred. Therefore, early detection of those situations where a slight shift occurs would be a preventive measure to mitigate any major accident. If we do a root cause analysis of why fatal four near misses occur, they occur majorly due to the unsafe act, which are driven by the physiological and the psychological indicators of construction workers. Workers' behavior constitute a prime cause for unsafe act, and personality traits are the integral part of those workers' behavior. Now, if I can direct your attention towards my research methodology, to reduce the number of fatal injuries, it is important to explore the dependency of big five personalities on near-miss recognition performance through visual attention under different external loading, such as mental loading, sensory loading, and physical loading. And through analysis of personality and visual sensing, we can improve the near-miss reporting that will supplement the reduction of fatal injuries. To put this methodology into action, the research framework was developed, and it included data acquisition of fatal four near-miss images from residential, commercial, and industrial sector, processing those images to mark the near-miss areas of interest and verifying them through a competent person, participant recruitment, experimental study, and using the data collection tools to evaluate the research question, and finally the analysis and results using statistical softwares and also visual sensing lab. The basic results or initial results based on the research question 1, which was the baseline study, showed a positive correlation between the personalities and also the visual attention of the participant, which were used by the fixation duration and fixation count.
1 minute.
Now, if I talk about the impact of this particular research, it has a profound impact on both construction industry and also academics. If we talk about the personalized near-miss training for workers with a low near-miss recognition capabilities, this could be implied. Automation of near-miss reporting system based on human behavior interaction with machine learning and artificial intelligence is one other industry impact. Reallocation of workers in different crews for efficient near-miss reporting. Increasing reporting will lead to increased intervention and finally reduce the fatalities. And also the capital spending reduction on bulk training through personalized trainings, or I should specify the personalized near-miss trainings. I mean, those who need it should get it. Why should everyone should do the same training over and over again? These are some of the industry impacts. Academic impact are the empirical evidence of the correlation between personality and near-miss. Thank you.
Many thanks for your presentation, Shashank. Now it's time for questions. Please, do you have some questions? Who wants to start? Yeah, Professor Puhan. Sure.
Yeah, first of all, thank you very much for the presentation. My question is on the linkage between personality and near-miss recognition. I would like to know, based on your experience and your interview, your experiments, and so on, do you find it more important? Do you find personality more related to the happening of near-miss incidents, or actually it is the health condition of the worker, or even the incidents that happened to the person probably the day before or some time ago, right? Some family issues that happened to the worker that would cause the near-miss incidents. Is it really the personality that matters?
I mean, if you look at, thank you so much for the question, but if you look at a point of view from a third person, if I'm observing a person going around, let me give you a scenario. If there's an opening in a floor, it's a hazard without barricaded. If there's a person in the vicinity of that floor, that's a near miss observed from a third person point of view. So if I'm observing those near misses, I should report them. But personally, if I'm the person who's going near the floor, then obviously the mental state, what happened a day before, how much alcohol consumption was there, or then the family tragedies, those things will come into picture. And those particular type of studies will require a plethora of data collection and also personalities in terms of participants to come for the study. But this study specifically focuses on a third person point of view on a person who's going near to the near miss.
Do we have any other question from the jurors? No? Okay. Now it's time to open questions for the audience, for the 3 participants under this stream on safety and occupational health. So do you have any questions? And please, if you have, just come here in front. No? Okay. With this time, we can now officially close the presentation session. And before passing the floor to my colleague, Shuruk Garif, on behalf of the AACEI Student Committee Montreal section, I would like to thank our jurors for accepting this important role and also for objectively selecting and evaluating the contestants. So now they will take a few minutes, but my colleague Shuruk Garif will guide you through the instructions and also for audience voting. Thank you very much.
Hello, everyone, again. As we just mentioned, that was our last session for today, and all audience will have the opportunity to vote for their presentation. But before taking our short break for voting, I would like to leave again the floor for Dana Shamsulahi to present to thank our sponsors and committee.
We are grateful to our sponsors, AC Montreal Section, Hatch, Turner and Townsend, HKA, and WSP for all of their generous support. I would like to recognize AAC student committee members who generously volunteered to expand this event and enhance the connection between academia and industry. Thank you. Abdelhadi Omar, Vice President and Financial Director, Araham Martinez, Planning and Logistics Director, Shuruk Garib, Communications and Public Relations Director, Amr Alam, Operational Director, Julia Fernandez, Jidobi Obifuna, Azadeh Sufipur, and Delaram Sadeghi, our student committee volunteers. Thank you all.
So now it's time for voting. Please, can you please share the QR code with us for the in-person audience? And in the chat, you will have the link to vote as well. And for the jury, you can please add juror to take your decision. We will have 15-minute break to take the decision. Thank you, everyone, and see you again.
Hello, everyone. We invite everyone to watch a small, short video from the committee and from everyone here. So thank you.
Bonjour tout le monde. Hello everyone. My name is Haji Ramani. I'm the current president of AACEI Montreal, Association for Advancement of Cost Engineering. It's an organization, an international organization who takes after professionals who are involved in project management, in project controls, different aspects of it. What we do in AACEI is to provide resources like recommended practices, certificates, courses, books, which really help grow the professionals and this industry itself in terms of practicing the best practices which are out there. In AACEI Montreal, we have a couple of events per year. We invite people to give talks around different topics of interest to the network. One of these events is the 3 minutes speech, which is expanding every year, and it's really a chance for the students to bring up with their ideas, to come up with their ideas, to present their topics, their theses, their projects, to the professional network for us to watch these ideas and to collaborate perhaps in future. If your idea is really good and well received and you're able to present it well, you may be able to walk away with one of the prizes. It doesn't matter really what you're involved with. At the end of the day, this is a great win-win for yourselves and for the AACEI and the crowd of project management controls in Montreal.
So hello everyone, we're back and thank you all for voting. Before announcing the winners still, we're gonna have Mr. McMullen to give us a speech. Thank you.
Thanks for the heads up. I'm just kidding. Okay. What, you want 30 minutes? 30 minutes, right? That's what she told me. Anyway, hello everybody. What an evening, what an event, another marvelous event by Concordia and Montreal section of AACE. So my name is Les McMullen. Those of you that have been around a long time know me because I have been around a long time. With the AACE Montreal section, I've been the past president for, it must have been at least 10, somewhere between 10 and 15 years at one point. I'm still on the board. And I also work for Hatch. I'm the global director of project controls at Hatch, where I've been for the last 8 years. So there's a few topics I want to talk about tonight's event. I want to talk a little bit about what we do and also what you as students can look forward to and what you can do to enhance your career. First, I want to tell you a little bit about AACE Montreal. Our current president is not here tonight, Hajir Amrani. We're good friends, go back many years. AACE, I saw a little video presentation I think the student committee had put together explaining why you should join AACE. Well, I joined AACE in 1982, actually, so I'm probably one of the longest running members besides Dr. Mazzelli, of course. And I started out my career after graduating from university. I was looking for a job. I got a job as a junior estimator. And I was a big government project here in Quebec up in Trois-Rivières. We were building a heavy water plant, which they later decided they didn't need after they had bought all the equipment and installed 6 300 feet GS towers. So that was my first experience, my first project. Saying, is that how projects go? You go on a project, then they cancel it? You know, I was kind of amazed. I said, what kind of business is this? Anyway, it was a big job. There were a lot of estimators, and I was the kid. I was the junior estimator. And they said, Les, you got to join ACE. I said, ACE, what has this got to do with tennis? Tennis ACE, or what is it? No idea. And in those days, it was called the American Association of Cost Engineers, which they changed later to the Association for the Advancement of Cost Engineering. But it was founded in 1956, I believe. My memory serves me correct, 1956. And how it was started, there was a group of engineers who got together in New England. There were a few Canadians, mostly Americans, and they were interested to know about unit costs and estimating. Remember, back in those days, in the Gulf Coast, they were building lots of refineries. If you've been in Houston and you drive, you can drive for miles and miles in its refineries. And of course, that's where the Gulf Coast standard comes from estimating, from all the work they were doing back there, all the analysis they did. So I'm giving you a little bit of a history lesson, but AACE was founded in 1961. I wasn't at the first meeting. And it's been going strong ever since. It's been going strong ever since. It's consecutively, all these years, it's been producing. We've had boards and presidents and directors, and it's had a really great life. In Montreal in the 1960s, 70s, all the consultants were here. So there was a lot of cost engineering. Montreal was kind of the center of cost engineering. And this I don't have to check on Google. I was around, at least in the early days there. So Montreal was the hub of engineering, and all the companies were here. So it was really a growing industry. So AACE over the years has been very closely associated with Concordia. I've known Professor Mazzelli, I think, 30 years. And he was one of our presidents, actually. And I don't know exactly what year, but it was a few years ago. And also Professor Mazdak Nickbach, he's currently on the board and continuing the great tradition we've had with Concordia. And over the years, we've had so many presentations here. We've brought special speakers up from ACE in the States. We've had certification programs, 2-3-day training programs given here. We've had so many things, I couldn't even remember them all that we've had over the years. Very strong connection with Concordia. And also, it's been my privilege to speak at different universities in Montreal, also McGill University. I've been at ETS. I've been at University of Sherbrooke presenting. So we've really had a really good association with the universities in the area in Montreal. And by the way, I think it was the first or second president was one of those group of men and women that met back in the 1950s. And he was actually, I think, one of our first presidents. And his name was Arthur Miller. And I always remember that because I think of the play Death of a Salesman was written by Arthur Miller. And it was not exactly the same spelling. I didn't get to meet Mr. Miller maybe 15 years ago. So that's a little bit of history of Montreal. It's been going strong. It's been increasing. There's more and more people interested in it because, you know, cost and schedule never gets old. It never gets old. Estimating, budgeting, forecasting, doesn't matter what you do. It never gets old. Earned value, contingency management, you know, risk analysis. So AACEI has a lot to offer, and I would encourage you, if you're a student, it's great, or even not a student, but if you're a student, it's a very reasonable price, and you get access to so much information. The library is 6,500 technical articles on every subject in the area. You have access to 100 recommended practices, how to write a basis of estimate, how to write a basis of schedule, all of these things. I told you I would be able to fill the time, but I warned you. But anyway, there's, in fact, many of these recommended practices, companies have taken them on board as their standard practices. So much to offer you. Anyway, I'm delighted to have attended another fantastic edition of the formerly the 3-minute thesis to the 3+1 competition. It keeps getting bigger every year, attracting students far and wide. And to hear the different topics today was very inspiring. And I can see the future is in good hands with the type of research that's being done today. I'd like to tell you just about Hatch for a minute and how we can tie it into this event. At Hatch, our vision is that we are passionately committed to the pursuit of a better world through positive change. And one of our mission statements, we have several, is that our exceptional diverse teams combine vast engineering knowledge and business knowledge, applying them to the world's toughest challenges. This is what we like to do. And as I listen to the diversity of the presentations today, I can see that many of you did look at some of the world's toughest challenges. We know there's so many challenges in the world today, from you know, pollution, the environment, you know, looking at greener projects in terms of you know, energy, clean energy. So many things need to be done. Infrastructure. We look at the infrastructure situation around the world. There's so many projects, different types of projects that need to be addressed. And to me, this is what I see the engineers at the universities doing, and that is looking at some of the world's toughest problems too, and actually coming up with some solutions through your research, looking at something that's going to help people. The presentations today about health and safety. We know that in construction, this is the most important thing in any project. It comes before cost control. It comes before planning, health and safety. We want people to be safe when they come to work in the office, when they go to a construction site. We want them to be prepared. When they use the facilities that we have been designed for 30 years, we want people to be safe and go home, so that you can never do too much about health and safety. Okay, that's number one. And I think all of us who are in this business will agree with that. So thanks to all of you for sharing your work and your ideas with us. Research and innovation is what propels us into an exciting future for a better world. And people like yourselves who have the passion to make a difference in this world can do that. They can do that. And research is so important, and research builds on previous research to the point where it becomes something that really can improve our planet. So today, this evening, we heard about BIM, one of our famous topics, which I first heard about, I think, 25 years ago. BIM's been around a long time. And digital delivery, that's the new hot topic today, and digital twins and the digital models, we're all into that. AI is burgeoning again. Again, AI was around in the early 1990s, but I think it was a little bit misunderstood, or some of it was just built into our software and it's just there. But I think today there's a much greater view of what AI can do, and I think we're going to see more and more developments out of AI. And of course, look, people lost it just 2 weeks ago when there's a little app they can go on and ask it questions, and it can reason like a human and have a conversation with you. I mean, people lost it, right? And then there was the other company that came out, was Google, and their little app gave the wrong answer, and suddenly the shares dropped by billions of dollars. So it's very uncertain as to what this will mean in the future, but for sure it's going to mean advantages to project controls and to the business we do. Even if you look at it as an expert assistant to some of the things that we're currently doing and replacing some of those things as well. We always say in project controls these days, we want to get away from the grunt work and do the analysis, the analytics. That's the new sexy thing is data analytics and data science, right? And that's growing as well. So we're going to see more and more applications. I know in our company we have data scientists. They're looking at ways to improve things. So the future is looking really interesting, really bright for us. What I like about the 4-minute presentation, one thing that's really important in our business, as much as the technical aspect, is the communication aspect, being able to communicate your ideas in a concise way. I was working with one university, and what they're doing is presentations where they're pretending they're consultants, and they've come up with a new technology or product. And I went and I taught them how to do basic estimating and to do basic planning so that they could put together their business plan with a little schedule and a budget. Because whatever you come up with, whatever your research leads to, if it leads to something that will go into production, there's going to be budgeting, there's going to be planning, there's going to be earned value, all the tools of the trade, all the things that we specialize in. I used to, in AACEI, I've met a number of Disney, they don't call them engineers, they're Disney Imagineers. And we've had presentations on some of the rides they've built in Disney World. Avatar, fluffy clouds. Well, behind the fluffy clouds, there's structural steel, and there's budgets, and there's quantities, and there's earned value. All the things that we hold dear in project controls. There's estimating and change orders. So, and so really this whole idea of, speaking, I think it's very important. So this class that I was talking to was basically showing them, how do you present to a client? And we've done it as consultants numerous times. We know what it's like to stand in front of a customer. We know how it is like to do the presentation, how to keep it short, sweet, the key items, things of interest, make it appealing. Because if you're going to, whether it's a client or you're going to an investor and you're trying to get funds for a project, you need to be able to communicate. You might have the best idea in the world, but if you can't communicate it, it may not actually take off. So this 4 minutes elevator speech is very good for that purpose. That it's going to teach you a little bit about how to communicate well, and given whatever time you have to communicate in. It's really important. So like I said, whatever type of projects, or regardless of what it is that you're involved with, that involve cost engineering, project control skills, planning, managing budgets, project execution strategy, understanding that. It's, tools such as digital project delivery make projects more efficient, cost effective, to get to that point where you can do the analysis and you're not just crunching numbers, as we used to say. And I think many of the tools today and some of the items we've talked about will give us that. So congratulations on your academic careers and the many opportunities it will afford you. I would encourage you to join professional associations such as AACEI, and there's others out there too that might catch your fancy. As I did a few years ago, more than a few out of university, it really bolstered my career and gave me the confidence, because in those days, there weren't a lot of universities really teaching this. Project controls is a field that many people get into without really seeking it out. They sort of fall into it because it's not commonly taught in the universities. It is in Concordia, for example, in construction management. So let me just wrap up by saying, if you join an organization, it teaches you about things that will benefit you, volunteerism, and the many benefits it will bring. Being part of a professional organization leads to more exposure. It leads to networking, recognition, more knowledge, and career opportunities. And we're very blessed too with the AACEI Montreal section, having the affiliation with Concordia and the student section. As you can see, they're very effective. They do great presentations and publicity. They keep the rest of the AACE section in Montreal on their toes because they're really up to date and really have helped promote the section to the point where we have more and more people attending. So, and that's what we want. You know, we have sections across the world connected. And it was my privilege to spend 4 years on the board of AACEI International and work with sections around the world. And it's just a tremendous organization. So I'm going to wrap up.
Thank you.
And it's all yours.
Thank you very much.
Thanks everybody very much.
All right, thank you very much, Les. What a great end to a great night. So everybody has thanked everyone, but I want to repeat again because I cannot thank enough these young fellows, the full brigade of AACEI Student Committee. Good job, guys. You keep raising the bar. I'm not sure where we're going to stop. I have the things that everybody is waiting for, but I want to tease you a little bit. Talking about the 70 plus years of history of Concordia. No, I'm joking, I'm not. So I'm gonna actually announce the winners because we're gonna be soon kicked out. Thank you so much to our basically hosts, the fourth space. I know that you're closing in a couple of minutes. I promise I wrap up by then. Thanks, Anna. All right. We usually have 3 winners. You all know how it would work. From this point, we have the 3 winners who will be invited for an extended version of their presentation next week, I believe, or the week after, in front of the AACE Montreal members. That would be basically 15 minutes, 10 to 15 minutes presentation. However, this year, thanks to our basically sponsors, we can give out more presents. So we're selecting actually 6, so twice as many. I'm gonna, and of course we have also the choice of the audience. So I'm gonna start from number 6 and move backward. Number 6, Mr. Mohammed Sharif, please. Good job, Mohammed. Number 5, Amir Hossein Sanatkar. Number 4, Austin McClymans. Congratulations to all the 3. And now we move on to the choice of the audience. So the audience choice, surprisingly enough, we had a tie between 2 winners. One is Saman Davari, and the other one is Ahmed Zaluk. Now, the 3 winners who will be invited for the extended presentation. Start with number 3. Kyung-Sung Lee from Purdue University. Number 2, Malcolm Dunson Todd from Concordia. Have a great night, everyone. Bye. Okay, and number 1, Ahmed Zaluk from Concordia University. Great incidents that the top choice of the jury met the top choice of the audience, so it's a great thing. I'm gonna take a few seconds to thank the jury. I cannot thank you enough. I hope this has been as interesting to you as it was for us. It's invaluable to have you around, and the type of inputs and insight and feedback that you provide is basically priceless to the audience. So thank you so much for your time. Also, I want to thank all the universities who attended this event. We had, can I have again the list of all universities? We were basically, we were fortunate because we had many high caliber universities sending abstracts to this event. And it was really, really tough job to select top 10. I don't want to say top 10, the 10 who best fit the scope of this event. The progress is at the level that can be presentable, and so on and so forth. So once again, big thank to all universities. You can see the full list of universities from all over the globe who sent abstracts, and specifically the 7 institutions that were in the competition. You see the logos from Louisiana State University, from University of Hawaii, Purdue, University of Maryland, Penn State University, and OTS, and of course, the one and only Concordia. Thank you so much, everyone, and we're looking forward to seeing you again next year when the 3+1 construction elevator pitch event.